So that brings me to my own research. In the WISE lab, we are doing research on various areas listed as here, and you can actually see the acronym spelled out here. I won't spend the time to do that, just to make sure that we stay on time here. So I'll show you some movies of what we're doing. So for example, this is here a collaboration with the NRC, the National Research Council Canada, and we're looking at turbine maintenance of aircraft turbines. Right? And so in this, one of the issues that we ran into when we talked about this was, how do we select? How do we actually interact with this digital model? And it's a very, there's things, inside things. So you have the issue that you have to basically deal with the insides of things, right? And it's not as if we can turn on X-ray vision. That's not very useful. And I've done some research on that, but so that's not directly very useful. But how do you actually select something inside other things? Right. Another application for this technology is the human body, right, where you have things inside things, right? And so here we're developing multiple techniques to try to basically make it easy for the user to select a target part that's somewhere inside and not obvious from the outside. Now, a lot of people think that you can just fly in there and look at it. I know that, but the issue with that issue is, when you fly in there, you may be basically somewhere where there's lots of other things right in front of you, and that doesn't make it useful. So what we're trying to do here is to come up with new ways to actually look at things that are inside. Oops, the audio shouldn't have been on here. Anyways, we just filmed this yesterday just to make it more clear. One of the other projects is to actually interact with high precision interaction in virtual reality. So now this is somebody in a virtual reality headset interacting with their cell phone on the arm so that they can have interaction like on a desktop. Now ignore the audio here. What we're targeting here is the highly complex menus that you'd have in a computer-aided design system or in some real system, right? PowerPoint or Word. One of the issues you run into is there's so many things you can do that. Right now, it's actually very difficult to map that into virtual and augmented reality. So what we're doing here is trying to come up with new solutions, better solutions to afford people to actually interact with very challenging systems that offer many, many different options. On following up now more on the data analytics side of digital twinning, here is a demonstration, a very simple demonstration, and I apologize for the camera work, but this is filmed basically from a head mount display, where we are looking at how we can present data in a virtual environment. And you can actually imagine here, and we could not get the video clip running to work for this, but you can imagine that you have data now around, say, that aircraft engine model, okay, and where we can grab dimensions, say, like compare weight and horsepower. And I've already talked with my students about the spelling mistakes in there, but that's just an unfortunate artifact, and basically quickly show the data, which is important if you want to look at diagnosing problems, say, why is that turbine not performing as well as it should? And we're talking here about a digital model of a turbine, but the data comes from a real turbine, right? And so in this case, we are trying to make a system that makes it very easy for the user to, say, compare different dimensions, different quantities, right? In this case, it's a car data set with horsepower and weight, right? And the colors, just in case you're wondering here, is the different Japanese cars versus European cars versus US cars, right? And so here we're making it very easy for the user to quickly put something together, look at the data, what is happening, what potential insights we can draw. We actually have this system running in a 2D version as well, where we have a large collaborative screen, and you can do this in virtual reality too. And one of the interesting things that was observed is that when you do that, you can suddenly do things like have people collaborate about the data, and people will start talking about the data and ignore the system, right? And that's a very powerful thing, to have people actually actively engage in the data. Oops. Another thing another project that we've done is to look at maintenance of aircraft here in this case, and we actually this is pictures of the system that I participated in building. And so this is basically a system that allows you to use a tablet like your average iPad or something like that, to actually look at the aircraft and basically use the tablet to annotate. Well, here there might be a problem or something like this, and then look up in the database which, say, component is underneath, right? So one of the issues turns out that tracking in the around an aircraft where that tablet is actually a very challenging issue. So in the bottom right image, you see that the digital model is overlaid over the real one, and you can see the two don't quite match. And so what we've done here is to adapt the method that's shown on the left here, where we can actually quickly move around an object, not in the sense of around a sphere. We've adapted that to the domain of an aircraft. And so in this case, we're now using a tablet here where we basically move the viewer alongside the aircraft while maintaining a reasonable distance to the aircraft, right? An aircraft is actually quite interesting because it has these wings, right? So if you stay always at the same distance to the body, you end up flying through the wings, which is very useless for an end user. So this method makes it easier to more robust for the user to navigate in the virtual model to match the real one. Last but not least, and this is a collaboration together with Purdue, we are looking at authoring of training videos. So now we are using digital models, in this case, a bike repair, where we actually author videos that demonstrate people how to train. And so we instrument, say here, the wrench and the bicycle here, so that we can actually do that. It turns out that authoring such videos is extremely time consuming and it needs lots of work. This system is targeted at somebody who doesn't know much about video editing and all of this, and to actually quickly generate, and they're subject matter artists, so they know how to, say, do a bicycle repair here, right? And how to make it easier for them. And so we have created a system.
Successful completion of the editing operation, the user can view the 2D video rendering of their creation.
So what you see here is actually recorded footage from the real world, right? Being played back in a virtual model to demonstrate how to do something, right? And now this is, of course, an example task, but we found this very beneficial and compared very well with other alternatives.